Continuing on with section 6.3, so this is still 6.3 in our textbook. We're going to take a look at the half angle formulas. So these are the formulas that we would use to find the sine, the cosine, and the tangent, which are half of some other angle that we know. When we take a look at these formulas, just a quick look to see if we can identify some patterns that would help us remember, become more familiar with them. We can see that all three of the formulas involve some sort of a square root, and we can also see that they all involve the cosine of some angle. They're calling them alpha, and here we could call them theta, but they're calling them alpha now. So some angle we don't know. The other thing that you notice down here is that tangent has three formulas that we might use. This one here, and then these two other formulas. This is similar to what we had with cosine in another, with one or the other. With the double angle formulas, it was cosine that had three options. Here, tangent has three options. And which formula you use depends on which one you want to use. The other thing, these two formulas here, we don't see any plus or minus signs, so the answer we get when we use this formula is the answer, and we don't have to worry about choosing a sign, plus or minus. However, bad news, looking at this formula here, at these three formulas, I should say, we see this plus minus, plus minus, plus minus. And as the notes down here says, this plus minus isn't like the plus minus in front of a square root function with the quadratic formula telling us there's two possible answers. No, 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 different here. This plus minus says that our answer could be a positive piece of information. It could be a negative piece of information. We are going to have to decide which it is based on the quadrant this half angle resides in. So this is a big change up from the formulas we've used so far, because the formulas up until now, we didn't have to concern ourselves with the plus or minus that went in front of our final answer. Obviously, we had to worry about it with the trig functions that we evaluated to use within our formula, but the formulas gave us the answers being positive or negative. With these formulas, we're going to have to make the choice. So let's get started with an example. In this first example, we want to find the cosine of 105 degrees. Well, 105 degrees is not an angle that we know. Now, we know from our sum and difference formulas, we could break 105 degrees down into 60 degrees and 45 degrees and use the sum, or in that case, it would be the addition, the sum formula for cosine. But because we're learning to use this half angle formula, we're going to use the half angle formula, and we're going to use 210. Why 210? Because 2 times 105 is 210 degrees, or 105. This is our alpha over 2, and that would be our alpha. So now, let's take a look while we're here at considering the quadrants we're in regards to our sines. 105, this angle here is in Q2, and 210 is in Q3. So we will probably be needing that information, most definitely, I should say, instead of probably, to determine our side. So while I'm here and I'm looking at it, let's take a look. So here, our formula says that the cosine of some angle divided by 2 is plus or minus the square root of 1 plus the cosine of the original angle divided by 2. So there's our formula. I just copied it from up here. Now we can start putting in some information. We are looking at our alpha over 2, or angle divided by 2, is 105 degrees. So this is going to be equal to, I'm going to leave the signs, this plus minus alone for a minute, 1 plus the cosine of 210 degrees over 2. So we put this information in. Now, plus or minus, because our angle here is R105 is in Q2. In Q2, our cosine is negative. So this is the sign that we're going to use. So the formula said think about plus or minus. We toss out the plus and we're only considering the negative sign. To continue here, we see that we need to have the cosine of 210 degrees. So let me come down here and let's take a look at this. So here's our 90, here's our 180 degrees, and so for our 210 degrees, we go here plus 180, and there is our angle alpha here that we're looking at. So 210 minus 180, our reference angle is going to be 30 degrees. So the cosine of our 210 degrees, to do that, we're going to look at the cosine of 30 degrees. And the cosine of 30 degrees is radical 3 over 2. Make sure I'm not off the paper, which I am. So we have the cosine of 30 degrees, radical 3 over 2. And now we are in the third quadrant here. In Q3, cosine is also negative, so the cosine of 210 is negative radical 3 over 2. So coming back up here to our formula, now we have equal to square root with the negative sign in front, and now we have 1 minus square root 3 over 2, because maybe I should have put plus minus. Sorry, I just jumped to the negative. Because this was an addition sign and this was negative, I just put the negative sign there. Hopefully you're all okay with that. And now this is all over 2. So we substituted in for the cosine of 210, and here we have our answer. And like so many of these problems we've looked at, the trig is usually the first 2 minutes of the problem, and the other 8 minutes is cleaning the thing up with algebra. So here we have this complex fraction thing going on. So in order to clear this denominator of 2, and I will put these over 1, so in case you need to see it, our denominator is 1, 1, 2. We're going to multiply everything by 2 to clear that fraction there. So this 2 and this 2 cancels. And now, looking like Christmas here with the red and green, sorry, negative here. We have 2 times 1, so we have 2. Here, these 2 cancel, so we're left with the square root of 3. And last but not least, down here in the denominator, 2 times 2 gives us 4. So we are just about done, but remember, when we have a radical, we don't want any radicals in the denominator. So we want to deal with this square root 4 in the denominator. Fortunately, 4 is a perfect square, so we can pull it out, and we have 2 minus the square root of 3 in the numerator, and the square root of 4 in the denominator is just this 2. So this is a pretty weird looking answer that we have a square root symbol, and then inside the square root symbol we have another square root symbol, but even though it's weird looking, it's okay. It is correct. So now let's look at this other example. Same idea, but this time instead of the angles being given to us in degrees, they're being given in radian measure. And again, we're going to be finding the tangent of an angle, 3 pi over 8, which isn't one that we know that we could do without the use of a calculator. And we're being told to do this using 3 pi over 4. Well, why 3 pi over 4? This is a simplified version. If we were to multiply this numerator and denominator by 2, we would get 6 pi over 8. So now we can see the reason we're using this is this 6 pi over 8 is double this angle here. So this would be our alpha over 2, and this is going to be our alpha. We're going to use the 3 pi over 4 form, the simplified, but it's the same idea. This is double this, or this is half this. This angle here is from Q1, and this angle here is from Q2. Again, we're going to need that information when we look at our formula. So looking at the formula now, tangent of alpha over 2, I am going to use this first one here for no other reason than I'm going to try to avoid having to rationalize using this thing with that square root. We might have to rationalize anyway, but this one is looking a little less intimidating to me. So I'm going to use that. You can use another one if you prefer. So now we have 1 minus the cosine of alpha all over the sine of alpha. So here is the formula we're going to use. And now we can see we're going to need to find the sine and cosine. So we had to find cosine before. Now we're going to have to find sine, but that's okay. We know how to do it. So looking over here, let's see if I can put these down here and leave enough room for the rest of the problem there. Here is our xy, and now here our angle we are going to use is 3 pi over 4. We're in Q2. So if we divide everything by 4, 1, 2, 3, and here is our angle there. So there's our angle. And the reference angle here we're going to use is pi over 4. So here's our alpha, there's our reference angle. So the, which one should we do first? Let's do cosine first. So the cosine of pi over 4, since that's what we're going to use, our reference angle, this is square root 2 over 2. And now in Q2 here, cosine is negative. So this is going to be negative. Now we also need the sine of pi over 4. Sine of pi over 4 is the same ratio. It's square root 2 over 2. But now in Q2, sine is positive, so we're going to use the positive version of that. So we have the information we need to come back up here. So now we have the tangent of 3 pi over 8, or half angle, is equal to 1 minus the cosine of 3 pi over 4 over the sine of 3 pi over 4. So here I've just substituted in the angles that we're using so you can keep track of how you would make those substitutions. And then over here, let's pop in our trig values. So we have 1, and now we have minus, and now the cosine is negative square root 2 over 2. And then the denominator, this is square root 2 over 2. So they're substituting in our trig ratios. Negative, negative, this would become positive. So I'm going to make that positive there. And so that helps simplify the sign sum. But again, we have this complex fraction going on where we have 2 and 2 in the denominator. And just to be consistent, I'll put this over 1 to show everything is a fraction. And similar to the previous example we did where the denominator we needed to deal with and get rid of is 2, we're going to multiply everything here by 2 also, all terms in the numerator and all terms in the denominator. So when we do this multiplication here, these 2's cancel and these 2's cancel, so we're left with 2 over here The 2's cancel, so square root of 2, remember this is now positive, and then in the denominator we have square root 2. So even though I chose the formula I did to try to avoid this situation, I wasn't so lucky because we still have this radical 2 in the denominator that we have to rationalize. So this means we're going to multiply up here by square root 2 and down in the denominator by square root 2. I'm going to put the numerator in parentheses because this is a distribution multiplication, and that parentheses might help you remember that it is a distribution multiplication and everything in the numerator gets multiplied by that square root 2. So 2 times square root 2 is 2 square root 2. Square root 2 times square root 2 is just 2. And then the denominator, square root 2 times 2, square root 2 is 2. So no more radical in the denominator, just about done. The one last step is we can see that we can divide by 2 here, here, and here. And when we do that, we have square root 2 plus 1. So this would cancel with this and this and this, and they all become 1s. I wasn't going to do that because it makes a mess, but so that you can see it.